What is the big blue wheel at CERN?
This big blue wheel is one of two wheels that are brand new detector components being added to the ATLAS experiment at the Large Hadron Collider at CERN. And that's a mouthful, so allow me to explain. The Large Hadron Collider is a 27-kilometer circular tunnel on the border of France and Switzerland, about 100 meters underground. And in this tunnel, we use superconducting magnets colder than outer space to accelerate protons, you're all made of protons, to 99.999999% of the speed of light in two opposite directions. And then at 4 points on the ring, we slam the protons together millions of times a second, briefly recreating the conditions of the universe as they were just a fraction of a second after the moment of the Big Bang 13.8 billion years ago. Side note, no, we're not actually making a new Big Bang at the Large Hadron Collider, just like when you install a saltwater aquarium in your home, you're not actually making a new ocean. Neither are we branching off multiple universes or anything like that. That's its own video. But record scratch, why would we want to do this? We have a large number of big open questions in physics, and to answer them, we need to learn more about what was happening just after the moment of the Big Bang, which is currently a mystery. And you can't do this by slamming together two baseballs. You need a more sophisticated experiment like the Large Hadron Collider and its very high energy proton collisions. And the places where we slam these protons together, we better build a gigantic detector, because quantum field theory magic, side note, not actually magic, is going to happen. ATLAS, my current experiment, is one of the 4 main detectors on the Large Hadron Collider ring. And ATLAS is 6 stories high, 46 meters long. It's like a big soda can tipped on its side and filled with complicated electronics and buried 100 meters under the ground. For a few weeks out of every year, we collide not just protons in the Large Hadron Collider, but in fact gigantic nuclei of elements like xenon and argon. And this back here is Lear, where they start their journey before they eventually get into the Large Hadron Collider. This right here is literal heavy metal physics. What riff you got on it? People are always asking me, hey James, can you show us the Stargate you have there at CERN? And I keep telling you, we don't have a Stargate. We have something much better. This. The ALICE experiment, 50 meters underground. Yes, this cross-section is more of an octagon, but here we are. One of the brand new muon wheels being added to the ATLAS experiment. Beautiful. A prototype solenoid magnet for a future fixed target experiment. The other side of the solenoid. This is now a video about things that are circular or approximately circular. In the amount of time it takes me to finish this sentence, about 10 trillion particles called neutrinos, ejected from the sun, will zoom through your thumb. These tiny ghost-like wisps have been bombarding the Earth for billions of years, and they essentially never leave behind a hint that they're there. You've certainly never felt them. But even though we understand quite a lot about them, neutrinos are still some of the most mysterious particles in nature, and they could potentially help us answer one of the biggest questions in physics. Why is our universe made of matter rather than antimatter? But to understand neutrinos better and potentially answer this question, we need to build experiments to produce and catch neutrinos. It turns out that producing neutrinos is easy, but how in the world are we supposed to catch them? Trillions and trillions of them pass through your body every second imperceptibly. Well, as often happens when we study the smallest things in nature, we need to go big. Very big. This is ProtoDUNE, a prototype here at CERN for a neutrino experiment called DUNE that will eventually be constructed at Fermilab near Chicago. And I'm going to be live streaming from right here inside ProtoDUNE this Friday for my regular Friday Q&A. Join me on September 17th at 1 p.m. Eastern.